This is lesson 7 from the matrix unit. This one will be looking at exercise 5H, identity and inverse matrices. So now that you got the hang of matrices in different contexts, how to add, subtract, scalar, and matrix multiplication, different contexts, communication, and connections. I'm hoping at this point that all of you will be pretty comfortable with matrices and how they work, how they operate, using your calculator, your classified calculator, to help you out as well. So in ordinary arithmetic, the number 1 is called the multiplicative identity element. In other words, when 1 multiplies a number, the answer is always identical to the original number. So 5 times 1 in English terms is saying how many lots of 1s are there, or how many lots of 5s are there if we multiply it by 1. In this case, because there's only one group of 5, your answer is 5. Okay, so the number 1 is the multiplicative identity. So when you look in matrices or into matrices, the question that we pose is there a matrix that can multiply any matrix and give an answer identical to the original matrix? Okay, you can add 0 to any matrix and be left with the same matrix. But this isn't asking if you can add something. This is asking if you can multiply a certain matrix, or certain matrix, to get the same result matrix at the end. So the identity matrix will go into an example. Let's go over there. Into an example. This matrix is a 2 by 2 matrix, 5, 2, 8, 3. And this matrix, that's matrix A. This matrix I is a 1, 0, 0, 1. You'll notice that there are 1s along the diagonal. We're going to find two things: what A times I is, matrix A times matrix I, and what matrix I times matrix A is. So same thing, just in different order. So when you apply the matrix multiplication, and you can double check this on your calculator, you'll end up with the same matrix that you ended up with. And if you did it the other way around, or you swapped the A and I around, again, you'll end up with the same matrix, 5, 2, 8, 3. So there is a matrix that can result in the same matrix when you multiply it with, namely this 1, 0, 0, 1 matrix here. Remember, at any point, you can ask the teacher to pause, or you can pause it yourself if you're watching it on your own device, to make sure that you can get the relevant notes down. So, an identity matrix for a 2 by 2 matrix, or 2 by 2 matrices. This identity matrix is 1, 0, 0, 1. Okay, and in this case, AI and IA, when you multiply that matrix with the identity matrix, you'll end up back at A. So this is what this line means. AI is the same as A, which is the same as IA. So the identity matrix has a special property that it is commutative. Okay? All that's saying is you can swap it around. AI is the same as IA. There is a commutative law that says that 2 times 3 is the same as 3 times 2, 6 times 5 is the same as 5 times 6. You can flip them around. So when I is one of the matrices in the multiplication, the answer is the same when the order of the matrices is commutative or reversed. So you got to remember that a matrix multiplication is not usually commutative. So only square matrices have identity matrices. The identity matrix for any square matrix is a square matrix of the same order with ones along the leading diagonal, or in other words, from top left to bottom right, and all the other elements contain the number 0. So here, this is a 1 by 1, so this is 1. Okay, that makes sense. 2 by 2, ones along the diagonal. 3 by 3, ones along the diagonal. 4 by 4, 5 by 5, 6 by 6, etc. All the other elements are the number 0. Now that we're seeing the identity matrix, we want to look at the inverse of a matrix. So they do go hand in hand with each other, and they do have a connection with each other. So written as a to the power of -1, so remember A is a matrix, so this matrix to the power of -1, the inverse of a matrix A is a matrix that multiplies A to produce or to make the identity matrix. Or in other words, if I have a matrix A, and it has to be a square matrix, and I find a certain matrix that's of the same order, that when you multiply those two matrices together through matrix multiplication, you end up with the identity matrix, or you end up with a leading diagonal of ones. Okay, so how you find that, there is a specific way. To get an intuitive feel of what's going on, you will use your calculator. This is also commutative as well, where A multiplied by its inverse matrix is also the same as getting that inverse matrix and multiplying it by matrix A. You'll end up with an identity matrix. Now, as I said before, only square matrices have inverses. Finding the inverse of a matrix is best done using your CAS calculator, or class-based calculator. But it is important to know how to find the inverse of a 2 by 2 matrix. To find an inverse of any other type of matrix can get quite tricky. But let's just look at the calculator version first. So, how to find an inverse of a matrix using calculator. We want to look for the inverse of 8432. At this point, I'm hoping that you guys should be familiar with inserting a matrix into your class-based calculator and assigning it a letter. We are going to insert this matrix here. So I'm going to grab my class-based calculator quickly. Seems to be taking a while. What I'll do is I'll quickly pause, and I'll hopefully you can have it up and running. Okay, sorry about that. So I've got my calculator out. It's a bit cropped because of the size of the screen. But I'll get my keyboard out, like so. To get the matrix function out, that's in Math 2. I want to create a 2 by 2 matrix. So just click straight to that one. I want to put the elements 8, 4, 3, 2, and assign that to the letter A. Okay, now that we've put that in, I am going to find the inverse of this. So I'm going to get the A. Now on your keyboard, not the keyboard part, but where the number pad is, there will be an option to put any element or any term, any matrix to the power of. Looks like a little up arrow. And all we're going to do is put that to the power of -1, and you will get the result of 0.5, -1, -0.75, and 2. Now, some people might have a different answer. Just double check here. Some people might have a different answer, and you might get this. Take this out. You might get the fraction form of the answer. If that's the case, there's still the same answer, but there is a button here, standard and decimal. Okay, alternating between the two of them will indicate what type of answer you will get. So whatever it says, that's what you will get. So now we've got the inverse of this matrix A, half, -1, -3/4, and 2. This indicates to me that if I get my original matrix A, 8, 4, 3, 2, and I multiply it with the inverse matrix, which the calculators found out, we don't know how to get this yet, but there is a method. When you multiply these two together, you will get the identity matrix of ones. In other words, if I compute that, I will get the answer of 1001. Now you can manually do this, but there's my identity matrix. So we know that this right here has to be the inverse. I'm going to leave it here. I'm going to make this 2 videos. So the second part you can see how to manually work out the inverse of a 2x2 matrix. So hopefully a teacher, or you can navigate to the next video. I'll see you then.